As we have understood what is being covered with respect to ELT data pipelines using Databricks in the previous lecture, in this lecture, let me walk you through the details about what is being covered with respect to performance tuning of Spark. At a high level, we have covered Catalyst Optimizer, how to configure clusters to run Spark applications, then performance tuning while inferring schema from CSV or JSON files. Also, we have gone through the details about using columnar file format and partitioning from the perspective of performance tuning. As part of Catalyst Optimizer, we have gone through the details related to overview of Catalyst Optimizer, then how to review explain plans related to Spark data frame as well as Spark SQL using Spark UI, and also how to generate explain plans using explain function on Spark data frames or explain command on Spark SQL queries. We have even covered the details about interpreting explain plan for Spark SQL query. It is similar to what we have seen earlier with respect to SQL using Postgres. Then we have gone to the details about reviewing Spark architecture, and also we have spent enough time to read the explain plans associated with the different types of operations. Once we go through all the details with respect to Catalyst Optimizer, then we have covered details from the perspective of cluster configuration using Databricks. We have gone to the differences between all-purpose and jobs clusters, and also we have gone to the details about setting up all-purpose Databricks compute clusters. Then we have gone to the details about understanding the size of the data using dbutils, then creating multi-node Databricks cluster with autoscaling, then autoscaling of Databricks clusters, performance tuning of cluster using autoscaling. We have even gone to the details about analyzing airlines data using Spark SQL. In this process, we have spent quite a lot of time in understanding how the performance will differ depending upon different cluster configurations. We have even gone through the details about setting up Databricks job compute clusters using workflows. Then we have gone through the details about reviewing running job details using Spark UI and also completed job details using Spark UI. Once we have gone through the details with respect to cluster configuration, we have even covered about performance tuning while inferring schema from CSV as well as JSON files. In this, I have even highlighted about the overhead related to the inferring schema so that we understand the relevance of performance tuning while inferring the schema. Finally, under performance tuning, we have even gone to the details about using columnar file format and also partitioning strategy. First, I have spoken about side effects of using CSV files in data lake. Some of the newcomers might get tempted to use CSV files, but in general, we don't use CSV files very often, except when it comes to learning or when it comes to loading the data from external sources. Once the data is loaded from external sources, typically we use standard formats such as Delta, Parquet, etc. Once we understand the side effects of using CSV files, we'll go to the details about restructuring CSV data to columnar format using PySpark. We will compute the size of restructured data using Parquet file format. We'll run operations on partitioned Parquet data. We'll also go to the details related to performance assessment of Spark jobs. We'll also go through the performance details for Spark operations on Parquet files. We will then get into the details related to overview of columnar file formats, why they should be used over CSV file format, so on and so forth. We'll also get into the details about overview of folder structure for partitioned data in Spark. We'll evaluate requirements against partition pruning. Then we'll actually get into the details with respect to performance tuning using partitions around airlines data. We'll also go to the execution details to understand whether the performance is improved or not. We'll also perform additional operations using date range without partition pruning to see what is going on internally without partition pruning so that we can compare with partition pruning. After going through all these details, we'll be fairly comfortable with performance tuning using columnar file formats or using partitioning strategies or both. In the end, we might end up using both of these strategies to solve some of the key performance problems. So using multiple scenarios, we'll be learning quite a few tricks and techniques with respect to performance tuning in Spark. On top of this, we will be learning even the details with respect to Catalyst Optimizer, which is backbone of executing our Spark code by Spark engine. You will understand all those details by the end of these 4 sections related to performance tuning.